Good morning all of you and Sairam to all. In this video we will go ahead with our motion chapter. So before going to start our new chapter, we will do a quick revision what we have learnt in our previous video. So let us start. What do you mean by motion? If there is any change of an object with respect to time and with respect to its surrounding is known as motion. See here, motion is defined as the change of position of an object with time or with respect to its surrounding is known as motion. Now, this I will explain with one example. A person is standing here at position A. After 5 minutes, this person will reach over here at position B, and there is one tree. Is there any change in this person position? Yes, there is a change in the position of this person. After 5 minutes, he reaches at point B. With respect to time also there is change, and with respect to surrounding also. Now, what do you mean by surrounding? The things which we are taking as a reference point. In this example, we have taken this tree as a reference point. So with this, I think motion is clear to you. I will read once more the definition of motion. Motion is defined as the change of position with time or with respect to its surrounding is known as motion. Now move to next one. What do you mean by rest? If there is no change in the position of an object with respect to its surrounding or with respect to its time is known as a object is at rest. For example, a tree is here, a person is standing here. After 5 minutes, if we will observe, this person will remain as here only. That means there is no movement, there is no change with respect to time, and there is no change with respect to its surrounding. So we can say that this person is at rest. With this, I think the difference between motion and rest is clear to you. If there is change in position with respect to its surrounding is known as motion, and if there is no change with respect to its surrounding and with respect to the time is known as the body is to be at rest. Now move on to next. We have done types of motion. There are 4 types of motion. First is rectilinear motion, second is circular motion, third is periodic motion, and the last one is rolling motion. Let us start with rectilinear motion. What do you mean by rectilinear motion? Movement in a straight line. Movement in a straight line is known as rectilinear motion. Example, marching of soldier, moving of a car in a straight line, moving of a train in a straight track. These all are the example of your rectilinear motion. So what is the definition of rectilinear motion? Movement in a straight line is called a rectilinear motion. Now circular motion. What do you mean by circular motion? Movement in a circular path about a fixed central plane is known as your circular motion. Example is, yes, your giant wheel. Now move to the next one. What do you mean by periodic motion? Movement that repeat itself after a certain interval of time is known as your periodic motion. All of you have seen the simple pendulum in your 8th standard. So simple pendulum is the example of your periodic motion. Now what do you mean by rolling motion? Rolling motion is a combination of 2 motion. First is your circular motion and second is your linear motion. Linear means rectilinear motion. These 2 combination of motion is known as your rolling motion. So one more time we will read our definition of each type of motion. First is movement in a straight line is called a rectilinear motion. movement in a circular path about a fixed central point is known as your circular motion. Movement that repeats itself after a certain interval of time is known as periodic motion. And what do you mean by rolling motion? Combination of both. That means combination of linear and circular motion together is known as your rolling motion. Now move to next. After that we have done physical quantity. What do you mean by physical quantity? Those quantity which you can express in the form of number. That means which you can express in the mathematical form is known as your physical quantity. Example, your time. Can you express time in number form? Exactly, you can express. Now distance. These all are the example of your physical quantity. But if I will talk about love, anger, respect, can you express in the number form? No, you can't express these terms in the number form. So these are not a physical quantity. So what is the definition of physical quantity? A physical quantity is any physical property that can be expressed in a number. That can be expressed in a number. If I will ask you to express 6 o'clock in a number form, you can write this. Like this you can express in the number form. So after that we have done that physical quantity divided into two parts. Like one is scalar quantity and one is vector quantity. These both quantities are different from each other. And what is the difference between these two quantities? In scalar quantity we will talk only about magnitude. We will not bother about any type of direction. So those quantity in which we consider only magnitude. What we consider? We consider only magnitude is known as your scalar quantity. And vector quantity are those in which we consider both. Both means direction as well as magnitude. This type of quantity is known as your vector quantity. So what is a scalar quantity? Scalar quantity are those quantity in which we consider only only magnitude, not direction. But in vector quantity we consider both direction as well as magnitude. Example of scalar quantity, time. You can't express time in the negative form. Distance. You can't express distance in the negative form. How? See one example. If the distance between your house to school is 5 kilometers, okay, and if I will ask you how much cover you daily from your home to school or school to home, you will say 10 kilometers. You will not say 0 kilometers. Why? Because if you will consider direction, so one side you will take as a positive and another side you will take as a negative, and 5 minus 5 will remain 0. So in distance we will not consider direction. So this is a physical quantity. And vector quantity are those in which we consider direction as well as magnitude. Example, velocity, displacement. These all are terms which we will go study in a further videos. Now after that we have done what is uniform motion sorry, what is uniform motion and what is non-uniform motion. Uniform motion is that motion in which an object covers equal distance in equal interval of time is known as your uniform motion. For example, if a person is standing over here, after in 5 minutes he covered 2 kilometers, and in next 5 minutes he covers 2 kilometers. So it means that person covers equal distance in equal interval of time. So this type of motion is known as your uniform motion. And uniform is constant. So it covers always constant distance in constant interval of time. Now non-uniform motion. Non-uniform means non-constant. That means a person covers unequal distance in unequal interval of time. Like in first 5 minutes it covers 2 kilometer, and next 5 minutes it covers 1 kilometer. So times are equal, but distance are equal? No. So it covers unequal distance in equal interval of time. Now, if we will talk about the graph of uniform and non-uniform motion, so the graph of uniform motion is a straight line. Why? Because it covers equal distance in equal interval of time. And if we are talking about non-uniform motion graph, so it will give you curve shaped graph like this. Why? Because it covers unequal distance in equal interval of time. So if I will ask you to write a difference between uniform motion and non-uniform motion, are you able to write? Yes. The first difference is in uniform means constant, non-uniform means non-constant. Second point is in uniform motion, object covers equal distance in equal interval of time. Here, in non-uniform motion, an object covers unequal distance in equal interval of time. So these all are the difference of uniform motion and non-uniform motion. Now with this we have done the revision of what we have learnt in our previous video. Now topics to be covered in this video are distance and displacement. So let us start with distance. Basically, the term distance means how far you travel. That means distance is measure how far an object travels over a certain period of time. Before going to explain distance, I would like to ask a question. So my question is, how far did object travel? See, a person is standing over here. Okay, he wants to reach here. Now my question is, how far did the object travel? Some construction was going here. So actually there are two ways to answer this question. First, by the getting of total path traveled by the object, or other is by measuring the initial and the final position, because some construction work is going over here. So that person will go here, then he will go here, then he will reach here. Okay, so one is this and one is this, you will calculate or you will measure the difference between the initial position and the final position, and both these two solution is termed as a different. First, this actual path covered by the object is known as the distance, and the other way what is that the distance between the initial and final position is known as your displacement. So distance is a measure of how far an object travels over a certain period of a time. Clear? Over a certain period of a time. Now, if we will talk about the SI unit of distance, so SI unit of distance is meter. You can measure the distance in kilometer, millimeter, centimeter also, but the SI unit is meter. When you will solve a numerical, you have to convert that meter, centimeter, kilometer into meter. Now, distance is a which type of quantity? Whether it is a scalar quantity or a vector quantity. Yes, it is a scalar quantity. Why? Because in this we will only consider magnitude. We will not consider direction. So, I gave you earlier one example about school or your home. Yes. So, we will read once more. What is distance? Distance is measure of how far an object travels over a certain period of time. Distance can be measured in any length units, including kilometers, millimeters, but it is usually converted into meters. I told you that if a distance is given into a kilometer and centimeter or millimeter form, you have to convert these units into meter. Why? Because the SI unit of distance is meter. Distance is a scalar quantity. Why? Because it has only magnitude. There is no direction. So, those quantity in which we consider only magnitude is known as your scalar quantity. Now your displacement is there. The other way is displacement. I told you earlier. What do you mean by displacement? The total difference, the total length between the initial and the final position is known as your displacement. So the definition is, displacement describes the change of position of an object and its direction over a certain period of time. Or you can say that the shortest distance between the initial position and the final position is known as displacement. Now, what is the SI unit of displacement? It is same as a distance. That means it is a meter. Now, whether it is a scalar quantity or a vector quantity? Yes, displacement is a vector quantity because we are consider direction in this vector. Why? See, if you are standing here, after 5 minutes you will reach here, and after 5 minutes you will come back here. So plus 5 and here negative 5. Why? Because we are considered direction in this case. So plus 5 and minus 5 is equal to 0. So with this you can say that your displacement can be 0. But if you are talking about distance, your distance cannot be 0. Why? Because you are not considering direction. If you will not consider direction, this 5 will become plus 5 will give you a 10 kilometer as an answer. So I will read this slide one more time. Displacement describes a change in position of an object and its direction over a certain period of time is known as displacement. Or in other language, you can say that it is a shortest distance between the initial and the final position of an object. The SI unit of a displacement can be meters. Third, the direction of the change in position can be described using compass point left or right or positive or negative. How can you will measure the direction? With the help of a compass needle. You can measure the direction. Now, displacement is a vector quantity. Why? Because in this we will consider both size and direction. I think with this, distance and displacement clear to you. Now, these are the two figures. Here, point A and point B is there. If I will ask about distance, so that person goes like this. So total distance is first A plus C, then C plus D, then D plus B. When you will add the distance between these points, is known as your distance. But if we are talking about displacement, directly A to B, these are the displacement. Now, what is the difference between distance and displacement? Distance cannot be negative, displacement can be negative. Why? Because in distance we are not considering direction. If we are not considering direction, so how minus sign will come? Clear? And in displacement we are considering direction. If we will take one direction as a positive, so second direction we have to take as a negative. Now, distance travel never decreases. You can't decrease the distance, but displacement can be decreases. How? Decreases or increases, both. It can be increases and decreases both. Distance is a which type of quantity? Distance is a scalar quantity. Why it is a scalar quantity? Because in which we are considering only magnitude. We are not considering direction. Displacement is a vector quantity. Why? Because here we are considering both direction as well as magnitude. Now, if we are talking about SI unit of distance and displacement, The SI unit of distance and displacement both are same. That means it is meter. Now we will do some question based on distance and displacement. Let us discuss. So, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. I told you your displacement can be zero. Why? Because in this we are considering direction. And when your displacement can be zero, when your initial and your final point will same, is the case when your displacement is zero. So this I will explain you. Listen. Yes, an object moving a certain distance can zero. Why? I told you that when your initial and final position is same. A person is standing here. It covers 10 kilometer. Okay, again he go back. So how much distance is covered? 10 kilometer. But if we are taking this 10 kilometer as a positive, so we have to take this 10 as a negative. Why? Because here we are considering direction. Okay, so now your final and initial position is same, or you can do that 10 minus 10. What you will get? You will get 0. So your displacement can be 0. So yes, an object moving a certain distance can have a 0 total displacement. Displacement refers to the shortest distance between the initial and final position of the object. Even if an object moves through a considerable distance, if it eventually comes back to its initial position, the corresponding displacement of the object will be 0. So there is only one case when your displacement can be 0, and what is that case? When your initial and your final position same. I think this answer is clear to you. Now move to next one. Which of the following is true for displacement? It cannot be 0. No, we have done recently, na, that your displacement can be 0. When in which case? When your distance and when your initial and final position will same. In that case, your displacement can be 0. So first one is false. False because displacement of an object which travels a certain distance and comes back to the initial position is 0. Now, second part. Its magnitude is greater than the distance traveled by the object. It is also false. It cannot be greater. It can be equal or shorter, but it cannot be greater. So it is false because the displacement of an object can be equal to but never greater than the distance traveled. With this, I think distance and displacement clear to you. Okay, so once again we will revise what is distance and what is displacement. Your distance is total path covered by an object is known as distance. Distance is a scalar quantity. SI unit of distance is meter. Displacement is the shortest distance between the initial and the final position. SI unit is meter, and it is a vector quantity. Why it is a vector quantity? In this we are considering both direction as well as magnitude. With this, distance and displacement topic is over. I think it is clear to you. Thank you and salam.